Hi everyone. So today we'll be doing another question from probability where the random experiment is throwing a pair of dice. Okay. So you see in this kind of random experiment what we are doing, we throwing two dice. You know the dice you use in playing Ludo game. So with the two dice will be thrown simultaneously and the outcomes of the two die will be noted down, which will be your okay, noted down. Okay, so the outcome will be a pair of numbers. Outcome will be a pair of numbers like this. First number will be from the outcome of the first die, and the second number will be the outcome of the second die. So a pair of number or ordered pair, this is also sometimes known as ordered pair, will be our outcome in each trial or in each throw of some pair of die. Okay, so in the question, so what is that? In a single throw of two die, find the probability of getting first event a total of 10, means sum of the numbers that came up on the two die should be 10. Second event a total of 9 or 11, that is the sum of the numbers on the two die will be either 9 or 11. Third, a sum greater than 9, and fourth, a doublet of even numbers. Doublet means the numbers on both the die will be same, that is doublet. So okay, and the numbers should be of even, that is a doublet of even number means two same even numbers will come up on the die after throwing. Okay, so we have to find the probability of these four events. Okay, and we'll be using the theoretical definition, that is probability of an event is number of outcomes favorable to the event E upon number of total possible outcomes of the experiment. So for that, first of all we have to find the all possible outcomes. Okay, so for finding the all possible outcomes we have to make this table. You see how is the table? So the horizontal row represents the numbers 1, 2, 3, 4, 5, 6, that is the numbers on the first die, and the vertical one represents the numbers on the second die 1, 2, 3, 4, 5, 6. Okay, so I have represented the first die as green and the second die as black. So now when the two dice are thrown simultaneously, so we can write down the all possible outcomes very easily. So I'm making from the table. So as you see, one already been entered, that is this ordered pair. So the green one is the of the first die, and the second the black one is the second die. So I've written on the second order. So this pair is an outcome. So let me now write down all the possible outcomes. So here 1 in the second, and let me write down 1 in the first also. Let me first fill up all the, that will be easier I think. Here 1 in the second, here in the first horizontal row, this 1 is fixed. It is the outcome in the second die. Okay, this is fixed. Now the first member of the ordered pair will be the outcome of the first die. So here it is 2, 3, 4, 5, 6. So I got 6 outcomes. Similarly I will be getting in the second row, that is I am filling up the second member with the outcome of the second. So this 2 is fixed, this 2 is fixed, this 2 is fixed, and I fill up the first position with the outcome of the first die. In this way we can go on filling up. Here 3 is the fixed member in the second place. Fill up the first member with the outcome of the first die. here again I can write the first member sorry this is green one I've taken as the second member. No, green one first member, yes, okay. Black one is the second member, okay, fine. So in this column the second member is your 4. Let me write down this one also. Here second member is 5, which is fixed. And here second member is fixed, 6. Okay, so let me fill up the position of the first place. Okay, so here it is 1, it will be same 1, 2, 3, 4, 5, 6. Similarly here 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So I have filled up the table which shows the all possible outcomes when a pair of die is thrown simultaneously. So from this I can find out what will be the total number of outcomes. You see 6 rows and 6 columns, so 6 into 6, 36. So 36 is the total number of possible outcomes. So let me write down. Okay, total number of all possible outcomes is equal to 6 column into 6 rows, that is 36 that we found. Okay, now we are in a position to find out the probability of all the 4 events. So let me use the first part. So in the first part, what is a total of 10. So a total of 10, you see, that is the total of 10 means sum of the outcomes or sum of the numbers coming up on the dice should be 10. So obviously you see in this there is no, you look at the diagonals. So 4 plus 6 is your, so in this column 4 plus 6 is this one. 4, this I can take. Then 5 plus 5 is also 10. Then 6, this one is also 10. So if you go through this diagonal, so I can write down for the first part, or E is your 6, 4, then 5, 5, 6, 4, 5, 5, and then 4, 6. So this is the event. Okay, 6 plus 4, 10, 5 plus 5, 10, 4 plus 6, 10. So a total of 10. So therefore the probability can be very easily find out. Probability of the event will be number of favorable outcome is 1, 2, 3 and total number is 36. So answer is 1 by 12. In this way. Now for the second part, what is our E? E is a total of 9 or 11. 9 or 11. So you see, from 1 to 3, in the third column I will be getting this. This 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 and 6. That is 4 elements in this diagonal. And 9 or 11. Let me first write down. Sum will be 9. So it will be 6, 3, 5, 4, 4, 5. And lastly, your 3, 6. Okay, now, so I have to add the outcomes also, because you see, or 9 or 11 is not it. So I have to add the outcomes also whose sum is 11. Sum 11 means, you see, in the 6, 6 plus 5, that means this one. This diagonal, 6, 5 and 5, 6. 6, 5 and 5, 6. So if you observe, look at the table. From the table, I can easily find out the elements of the event. So therefore, let's do it. 1, 2, 3. Okay, so we can very easily now find out. Therefore, the probability of the event will be number of favorable outcome. How many? 1, 2, 3, 4, 5, 6. And total number outcome is 36. So the answer is 1 by 6. Now the third part, what will be the event? In the third part, what is a sum greater than 9? Okay. A sum greater than 9. Now you see, a sum will be 9 when 6 plus 3 is 9. You see this one, 6, these diagonals, this 6, 3, 5, 4, 4, 5, this is up to this, the sum is 9. So all the numbers in the left side of this line will be, sum will be less than 9, and all the numbers on the right side of this line will be, sum will be greater than 9. So obviously, how many are be greater than 9? So these diagonal plus these diagonal. So 1, 2, 3, 4, 5, 6. 6 elements are there. So it is 6 by 36. So it is also 1 by 6. So this I have not written. You can write on very easily. I think you understood. So this is this diagonal represents sum 9. So there are 2 more diagonals now. 3 diagonals. Sorry. That is this one. 4, 6. 5, 5, 6, 4 is one diagonal. Then 5, 6, 6, 5 is another diagonal. And last one is 6, 6. So I have taken all this side. So there are 6 elements. As I have shown you, 1, 2, 3, 4, 5, 6. So this 6 by 36, 1 by 6. I think you understood. And lastly, the fourth part. Fourth part, what is E? These even doublets. Now what are the doublets? You see, that is a column. Just you see, this 2, 2 is a doublet. So if this one, this is this diagonal 1, 2, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This diagonal contains all the doublets, is not it? There are 6 doublets, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So but we have to take only even doublets, so I'll take 2, 2, 4, 4 and 6, 6. 2, 2, 4, 4 and 6, 6. So these are the even doublets. Therefore, the probability will be favorable cases 1, 2, 3, and your total number of cases 36. So it is 1 by 12. So in this way, we find out the probability by observing the sample space or the table of all possible outcomes and writing down the elements corresponding to each event, and by following this definition we can very easily find out the probabilities. Okay, main thing you have to write down the table correctly and observe properly. Okay, so now let me solve another question from this using this table. Okay, now the next question. Next question, again the same random experiment. In a single throw of 2 die, find the probability of getting 2 at least once. Okay, so that means when I throw the die, throw the 2 die simultaneously, so we have to find the probability that at least once the number 2 will come up in the 2 die. That means minimum in one die that 2 should come up. It may be okay that if 2 is coming on both the die, but minimum in one die the 2 should come up. That is the event, and we have to find the probability of that event. Okay, so the same sample space or these are the all possible cases in the table that we have explained in the last question. So now main thing we have to find the event, the number of favorable outcomes to this event. So getting 2 at least once. So you see, look at this table. So in the column of 2, all these outcomes we are having 2. here in this case 2 is coming in both the die, this one. In this 2 is coming in both the die, okay. Here in the first die 2 is coming in the first die. Then you, so I have taken this one, this column. In this column 2 is coming in the first die and in this both the die. And if I consider this row, here 2 is coming in the second die. So, and in the rest of the numbers there are no 2. Okay. So obviously I have to consider the outcomes of this column and this row. Okay. And this one 2 is common. This is common where this 2 is coming both the die. So simply count. There are 6 numbers here, 6 outcomes here, and there are, if I exclude this, 1, 2, 3, 4, 5. So 5 plus 6, 11 outcomes are favorable. So let me write down in this way: 2, 1, 2, 2, dot dot up to 2, 6. This is then 1, 2. I will not take this 2, 2 because it's already taken. So 1, 3. Oh, sorry. Just a minute. This one, I have taken this one. I have to take this 1, 2, 2, 2. I will not take, then 3, 2. I will be taking this 3, 2. 3, 2. Then 4, 2. 5, 2. And then 6, 2. This will be our event. So therefore the probability of this event will be, number of outcomes favorable to this is 11, as I have told you. 5 here and 6 in this way. So 5 plus 6, 11, and total number of outcome is 36. So this is the answer. Now this will be the probability for any number to come at least once. So if I take 5, if the question is like that, find the probability of getting 5 to come, getting 5 at least once, then what will I do? I will take this column of 5 and this row of 5, and this 5 will be taken once, so it will be again same, 11 by 36. Similarly, if it is for 1, then again I will take this column of 1 and this row of 1, and this 1 will be common, so it will be again 5 plus 6, 11 by 36. So for all the numbers to come up at least once, this will be the probability 11 by 36. Now there may be a question where you have to find out that find the probability that this number will not come up. Then what you have to do? The simple thing, that will be the complementary event, because it will not come up. So it will come at least once, so it will not come up means it will be complementary of that event. So in that case it will be what? 1 minus PE. In this way you can solve. 36 minus 11, so it will be 25. So in that case that will be the, in this way we can find out very easily. So you have to understand the meaning of the event, what is meant by that, so that you can find out the correct elements of the event, and this you know how to write down the sample space or the all possible outcomes. I have shown you how to make the table. So I think you will be able to solve any kind of question relating the throw of pair of die. Only this is fixed, this number will be always 36. Only you have to understand the event whose probability you have to find out. Okay, so that's you need only observation and understanding and observation. So I think you'll be able to solve any kind of question of this type. Okay, so that's all for today. Bye.